So I'd like to talk about how to improve presidential elections. And I think it's pretty clear that there's a great deal of room for improvement. Exhibit A in that claim Exhibit A is the fact that Donald Trump is president. Now, we might all ask, how could this have happened? And I suspect that people will be debating that topic for many years to come. I'm going to give a very mechanical, straightforward answer. Trump became president because first, he got the Republican nomination. He won primaries in 36 states. But the striking fact about the Republican primaries in 2016 was that in none of the first 17 primaries that Trump won did he get a majority of the vote. The anti-Trump vote was bigger than the pro-Trump vote. Now that at first might seem surprising, but of course there's no contradiction because although he got less than a majority in those 17 states, he was facing multiple opponents. He was facing Marco Rubio, Ted Cruz, John Kasich, and about 13 other Republican candidates. And so the anti-Trump vote was split. Now, given how extreme Trump was, he might well have lost had there been just a single Republican, mainstream Republican facing him. And in fact, there's some pretty good evidence suggesting that he would have lost to either Ted Cruz or Marco Rubio. The polls in early March suggested that both those candidates were more popular than Trump in a head-to-head contest. But the fact that they both ran and a lot of other Republicans ran meant that Trump was ensured a nomination. So this can happen in the United States because we use what is called plurality rule as our primary election method. It's also sometimes called first past the post. Each voter votes for one candidate, and the winner is simply the candidate with the most votes, even if that's well short of a majority. And as I've just pointed out, plurality rule is highly vulnerable to vote splitting, by which I mean if there are two or more similar candidates, they can split the vote, and that allows a very different sort of candidate, perhaps a less popular candidate, to actually win. And that brings up my main topic, which is, can we do better? Is there a better way of electing presidents? And I would suggest that the answer is yes. And the first way of getting at that answer is to note that our current system really does not provide enough information about voters' preferences because voters can just indicate their top choice. They can't say anything about other candidates. So as I noted, Rubio or Kasich might well have defeated Trump head to head, but there was no way of knowing that given our current election system because that information was not collected from voters. So part of the solution is to allow voters to provide more information, to provide a ranking of candidates. So perhaps a voter might put Rubio first and then Kasich and then Trump, or some voters might put Trump first and then Kasich and then Rubio. So voters will be ranking candidates rather than just indicating their top choice. And then the question is, well, what do we do with these rankings? And I'd like to argue that actually a very old method, a method proposed by the Marquis de Condorcet in the 18th century, is a good way to go in determining the winner. What Condorcet argued was that voters should rank candidates, and then we should elect the candidates who, according to the rank, beat each of the other candidates in a head-to-head contest. So, for example, suppose that the Republican voters in the 2016 primaries broke down into three groups. 40% were Trump supporters. They put Trump first, and then Kasich, and then Rubio. 35 were Rubio supporters. 25% were Kasich supporters. Now, under our current system, you see Trump wins because he has 40% of the support, but actually Kasich is the majority winner. Kasich beats Trump by a majority because these voters, the voters in the middle, prefer Kasich to Trump, and the voters over on the right prefer Kasich to Trump, and that's 60%. And Kasich also defeats Rubio. These voters prefer Kasich to Rubio, and these voters prefer Kasich to Rubio, and that's 65%. So Kasich is the true majority winner. Now, I'm going to argue for true majority rule, but once voters have submitted rankings, there are many other systems besides true majority rule, which also become possible. And you might ask, well, why should we concentrate on majority rule? For example, we might use what is called the Borda count, which was proposed by Jean-Charles Borda at almost the same time that Condorcet was proposing majority rule. And Borda was a contemporary in 18th century France of Condorcet's. So under the Borda counts, and you've probably used this method, if there are three candidates and voters rank these three candidates, a candidate gets 3 points every time she's ranked first, and 2 points when she's ranked second, and 1 point when she's ranked third. And then we just add up the points, and whoever gets the most points is ranked first, and whoever gets the second most is ranked second, and so on. So here's an example. Suppose there are two groups of voters. 45% have the ranking Trump, Rubio, Kasich. 55% have the ranking Kasich, Trump, Rubio. Well, even though a majority prefer Kasich, notice that Trump actually gets more points than Kasich, because Kasich is ranked third by the Trump voters, and Trump is ranked second by the Kasich voters. So I'm not going to go through the calculation, but you can verify that is the Borda winner in this example. So we might ask, which method is better, the Borda count or majority rule? Now, the way that a voting theorist like me tries to answer this question is to first step back and ask, well, what principles do we want good voting rules to satisfy? Let's first look at those principles, and then let's check to see which method comes closest to satisfying those principles. Now, what are the standard principles that we ask for in a good voting method? Well, there's what's sometimes called the consensus principle. Economists call it the Pareto principle. If all voters agree that candidate A is better than candidate B, then B shouldn't be elected. It would be a very perverse system that would elect B. And not surprisingly, the consensus principle is satisfied by both majority rule and the Borda count. Another pretty obvious principle is the equal treatment principle, the idea that all voters should count equally. This is called the anonymity principle. in voting theory because it says that voters' names shouldn't matter, only their vote should matter. So all voters count equally. And again, both true majority rule and board count satisfy this. Interestingly, the Electoral College, which we use in general elections for president, violates this because which state you come from makes a difference, and that violates anonymity. Another basic principle is neutrality, which is equal treatment of candidates. All candidates should be treated equally. And again, true majority rule and the board account satisfy neutrality. So far there's no difference between true majority rule and Borda, but the next principle does serve to distinguish them, and that's the phenomenon that I was talking about at the beginning, which is vote splitting. The no vote splitting principle says that if an electorate is deciding between A and B, it shouldn't matter in determining which wins whether some irrelevant candidate C is running or not. Now, true majority rule clearly satisfies this no vote splitting principle, because if a majority of voters prefer A to B and also prefer A to C, if C is running, well, A is the winner in that case, but A will also be the winner if C doesn't run because a majority prefer A to B. So adding or subtracting candidates who have no chance of winning makes no difference. But that's not true of the board accounts. Board of voting violates no vote splitting. And here's an example. This is the example I used a few minutes ago to talk about the board accounts. Notice that, as I said before, Trump wins in this scenario when 45% are Trump voters, 55% are Kasich voters, but that's only because Rubio is running. If Rubio didn't run, then it would be a two-person race between Trump and Kasich, and now Kasich would win because the majority prefer him. So the board account violates the no vote splitting principle. So we see that so far, true majority rule is better than the board accounts because it satisfies all four principles that I've talked about: consensus, anonymity, and neutrality. Board account violates, and also no vote splitting. But the board account violates no vote splitting. Unfortunately, there's another principle that we want to have, which majority rule violates. And that's the principle that there should always be a clear-cut winner. In majority rule, that's not always the case. And here's an example. This is a three-candidate race where the population divides roughly equally into three groups. Notice that there is no majority winner here. Kasich is not the majority winner because there's a majority who prefer Rubio. These people prefer Rubio to Kasich, and these people prefer Rubio to Kasich, and that's 68%. But Rubio can't be the majority winner because Trump beats Rubio. These people prefer Trump to Rubio, and so do these, and that's 67%. But Trump can't be the majority winner because Kasich beats Trump. These people prefer Kasich to Trump, and these people prefer Kasich to Trump. So this is what's called a Condorcet cycle. Condorcet himself knew this could happen, and that means that the majority rule violates the decisiveness principle, the idea that there should always be a clear-cut winner. Borda satisfies decisiveness. So majority rule satisfies 4 out of our 5 principles. Borda satisfies 4 out of our 5 principles, not the same ones. We might ask, is there any rule that satisfies all 5 principles? Unfortunately, the answer to that is no, and that was established almost 70 years ago by the Arrow impossibility theorem. There is no voting method that satisfies all 5 principles. But I would argue that Arrow's theorem is too negative because it insists that an election method must work regardless of what rankings voters turn out to have. In reality, some rankings might be quite unlikely. For example, coming back to Trump, I think it's accurate to say that most Republicans either love Trump or they hate him. And they would either rank him first or last. But although that polarization may be bad for the Republican Party and may be bad for the country, it's actually very good for majority rule, because if voters are polarized in the sense that Trump is never ranked second, he's ranked first or third among 3 candidates, then we can't have the sort of paradoxical Condorcet cycle that I showed you a moment ago. And let's define a voting rule to work well for a particular class of rankings if it satisfies all 5 principles. Voters' rankings are drawn from that class. So for example, true majority rule works well when voters are limited to polarized rankings. They would never put Trump in the middle. And now we come to the main result I want to tell you about, which can be called the domination theorem. It's something that I developed with my co-author, Partha Dasgupta, and it says this: take some voting method that works well in the sense I just defined for a particular class of rankings. Then it must be the case that true majority rule also works well for that same class. And furthermore, there will exist some other class of rankings where majority rule works well, but the voting rule that we started with does not. And that means that there's a precise sense in which true majority rule works well more often than any other method, because if some method works well in some circumstances, true majority rule must also work well in those circumstances, and there will be other circumstances where true majority rule works well and the other method does not. Now, let me close by asking, will we ever see true majority rule used for presidential elections or other sorts of elections? And I think there's cause for optimism, because at least in this country, we don't need national laws on voting methods. Each state can decide for itself how its citizens are going to vote. And there is a method quite similar to true majority rule called ranked choice voting, which has been used in a number of cities around the country quite successfully. New York just adopted it last year. And in fact, ranked choice voting was adopted by the state of Maine for federal elections 2 years ago. And there's a good chance that Massachusetts will be adopting ranked choice voting this year. It's going to be on the ballot in Massachusetts in November. So I think we're moving in the right direction, and I'm optimistic about the future. It's time to get rid of plurality rule. Thank you.
Okay, great. So thanks very much for this invitation. Very hard to follow Eric, but I'll do my best. So before I talk about hybrid prediction markets, I'd like to start by just talking about classical or traditional prediction markets, which have been around for about 30 years or so. And these are just modeled on standard stock markets or futures and options markets for the trading of more traditional financial securities. The only difference really is the types of contracts that are traded over here. And these are state contingent securities, sometimes called binary options or event futures. And the idea is basically that you buy a contract and it references an underlying event. And if the event occurs, you get paid a fixed amount. And if it doesn't occur, you get paid nothing. So they're very risky contracts. But they trade in exactly the same way as stocks trade on an electronic exchange. Basically, the process is referred to as a continuous double auction. People submit orders that specify both the price and quantity. These orders will either trade if they are consistent with something that came before and is still waiting, or they will enter into an order book and wait for subsequent orders to come and trade against them. And the idea of the prediction market is to harness the wisdom of crowds and quickly aggregate distributed information. And it's believed that this would generate better forecasts than alternative approaches. And there's some evidence to support this. But so let's take a look at what predicted. So this is the main sort of legally operating market in the United States at the moment. Many of you will be familiar with it. So these are, this map just basically reflects the prices on 50 different markets, one for each state. And the colors tell you who's ahead in terms of which price, whether it's the Democratic or the Republican nominee's price is above 50 cents to the dollar. And the shading or the color intensity tells you by how much. So you can see that the lighter shaded states are close, and you can see how they're split. And I'll come back to what this map is telling us in a bit. So suppose if you look at Wisconsin, this is from a couple of days ago, but the prices are about the same today. Suppose you believe that the Democratic candidate would win Wisconsin with 70 or 75% chance. Well, in that case, you might want to buy a contract, which is available right here. You can see on this slide for 66 cents. And that'll terminate, that'll give you a payoff of $1 if the event actually occurs. So if you buy 100 shares on Wisconsin, Democrats to win Wisconsin at 66, that will pay off with $1 if that happens, and you lose your 66 cents otherwise. Now, with predicted, you're going to have to pay a fee, a 10% fee on the profits. You don't pay anything if you lose. And that's going to distort this market in a way that I'll describe in just a second. So if you look at the market, for the overall outcome, who's going to actually win the presidency, you see that the market is predicting a roughly 60-40 outcome, at least in terms of the probabilities, if you interpret the prices as probabilities. Now, a problem with interpreting these prices as probabilities is that that fee structure actually distorts the prices, and the sum of the prices can depart quite a bit from 1, which is what you need in order to interpret as probabilities. So I won't go into that, but despite those distortions, roughly speaking, you can say that the market is predicting about a 60-40 election. Okay, what about models? So model-based forecasting takes a completely different approach. You have pre-selected variables. They're estimated using historical data. So in this case, for election forecasting, it would be polls, approval ratings, economic indicators, partisan lean, and so on. There are a whole bunch of such forecasts out there. One of the most interesting ones actually is by The Economist, which I'll go through in just a second. So here's The Economist forecast by the states, very similar to the predicted forecast. You can compare state by state by just going to this website and comparing it to the predicted website. And the Electoral College prediction is also not that different. But here you see a really big difference. So the bottom line with regard to the election, this is not a 60-40 election according to the Economist model. It's more like an 80-20 election. So why the difference, and which one should we take more seriously? So clearly, these two forecasts are mutually inconsistent. So in thinking about that, let's think about the shortcomings of each of these two approaches and see if we can construct a hybrid approach that can leverage their strengths without falling prey to the shortcomings. So with markets, and this is true with the Iowa electronic markets right now, you can have limited liquidity. There can be thin markets, wide spreads between the buy and sell prices, not much participation for some markets, but that's definitely not true for predicted, where you have millions of contracts traded on a daily basis. There can be incentives for manipulation, and I want to talk about this a bit based on some prior research with David Rothschild, that people may have an incentive to try to manipulate the prediction market prices if they're taken seriously by the public at large. And the reasons for this we'll get to in just a second. I've already talked about the fee structure distortions. Those are relatively minor distortions. Now, there are disadvantages with models also. So with models, you need to identify relevant variables ahead of time. And you are limited to a small set of predictors to avoid overfitting when you're testing with historical data. And of course, there's a lag between the appearance of news and conventional metrics. So for example, if a campaign rally is scheduled, or a governor changes policy, or mask use is made mandatory, these kind of policies are going to show up in data only after a period of time. Markets can react to this much more quickly than the models can, because the models are, will be based on things like opinion polls, which may not reflect these changes for quite some time. So before I get to hybrid prediction markets, let me just talk about some work with David Rothschild that looked at data. This is extraordinarily detailed data from InTrade, which no longer exists, but was very important for the 2008 and 2012 presidential elections in the United States. And we had data on every single transaction for the 2-year period preceding the 2012 election. And we looked at 13 million contracts, about or close to 300,000 transactions, 6,300 unique trader accounts. Now, we don't know who these traders are, but for every transaction, the buyer and the seller, the accounts that are involved in the transaction are tagged. And so we can trace all the transactions associated with a given account over this entire two-year period. And from that, we can sort of construct an ecology of the market. It actually tells us quite a bit on how this particular market, and we think actually more generally financial markets, actually aggregate information. You have a real rich ecology of trading strategies. They interact with each other, and the resulting price is the outcome of this interaction that evolves over time as different accounts get larger and smaller and strategies change and so on. I won't go through this in much detail. I can refer you to the paper if you like, but basically a few small traders dominate this market. So this is in a log scale. Total volume is the number of contracts purchased, and the transactions is the number of trades. And each point here refers to an individual trader. There's 6,300 of them. And a whole bunch of people will just trade once or twice. You can see that on the left, although they may have a large trade. But right up there at the top, you get people who trade very frequently and in large amounts. So this slide contains a lot of information about the top 10 traders, but I just wanted to focus on the top 2 rows, the 2 largest traders who traded 4 million and 2 million contracts roughly, respectively, through 70,000 trades in the case of trader A and almost 23,000 in the case of trader B. And these are completely different strategies that they're adopting. Trader A adopted an algorithmic strategy, and the margin that you see on the column towards the right is the total amount of money that was at risk, the most that this trader ever risked at any point in time. And it's about less than $10,000. The profit made was about over 60,000. Trader B risked $7 million almost and lost the whole lot. And so this person was following a very different strategy. Let me just quickly show you these strategies and I'll get to the hybrid market. So this is what trader A did. So this is algorithmically implemented and basically was betting against Romney and Obama virtually simultaneously whenever the prices reached such a point where you could bet against them both and make a risk-free guaranteed profit, basically an arbitrage strategy. This would be implemented by this trader. And often the time that elapsed between the selling of the Romney and the selling of the Obama was less than 1 millisecond. So they have the exact same timestamp. And this is basically a risk-free strategy, not much risk involved at all, but you make a small amount through 70,000 different trades. And so this trader managed to make money without risk. And this is part of the ecology of a prediction market and more generally a financial market. Here's what the other trader did and just kept betting on Romney and against Obama over the entire 2-year period, accelerating towards the end. And there's evidence in the paper. It's not decisive, but we suggest that there may be some manipulation involved here in the sense that the trader was trying to put a floor on the price of Romney and a ceiling on the price of Obama. And in election prediction markets, there's a positive feedback effect. Actually, when we posted this, it attracted a fair amount of attention. People are trying to figure out who this was, who lost millions and why they were doing it. But basically, why would you do that, and how can manipulation actually be effective? It's because there's a positive feedback effect in beliefs about elections, what political scientists sometimes call bandwagon effects, where if somebody is believed to have a very low likelihood of success, that can have an effect on fundraising, morale, turnout. And this is why campaigns will often release internal posts that are favorable and suppress ones that are not. And if you can manipulate the market price in such a way that makes people more optimistic about your candidate, that belief can then become self-fulfilling. It can keep a campaign viable, which would otherwise move towards a failure. And the cost of manipulation, even $7 million, is really small compared to the cost of campaigns these days and how much money is spent on even a single primetime ad. But there's a paradox at the heart of prediction markets, which is that the incentive to manipulate only exists if the market is actually taken seriously, and the market will be taken seriously only if it's not manipulated, if it's perceived to be unmanipulated. And so there's a limit to the degree of manipulation, just as there's a limit to forecasting accuracy. It's sort of self-limiting. So that leads to the final question I just want to wrap up with, which can we somehow integrate the model approach and the human judgment approach? And part of what I'll describe right now is funded by a grant from IARPA under the hybrid forecasting competition. And I was part of a team that was led by Aram Galsyan from University of Southern California called SAGE, Synergistic Anticipation of Geopolitical Events. This is a successor to the same IARPA-funded aggregative contingent estimation competition, the ACE competition that was won by the Good Judgment Project you have read or heard about. And the idea was to have hybrid forecasts that combine machine models with human judgment in some way. But there were severe constraints imposed on the development of machine models. They had to be developed before you knew exactly what the questions that they would be used for were disclosed. So the models could not be tailored to specific questions like elections or disease prevalence, and they had a broad scope of preference. And I have to add that all IARPA questions were pertaining only to non-US countries. That's the scope of the grant. So these are sort of examples of questions. Will there be a W2 dispute between country A and country B? Temperature anomaly, cyclones, floods, civilian fatalities and civil conflicts, and so on. And the models have to be constructed before these questions are revealed. They have to just pick out keywords and databases in the questions to try to forecast. So this severely limits the ability to develop effective machine models. And I'll come back to this point in the last minute or two that I have left. So in order to try to create a hybrid forecasting platform, one of the approaches, and I should say the team took many, many different approaches, but one of the approaches was to develop hybrid prediction markets. And I'll describe to you what this looks like without presenting you any results. We are still in the process of testing and thinking about applications. So I'll just give you the design, not any particular performance indicators. So a hybrid prediction market basically is a prediction market in which a model-based forecast is represented by a trading bot that acts as if it believes that forecast, is endowed with risk preferences and a budget. Those preferences can be tuned, and it basically just acts like any other trader. But when the model changes, it changes its beliefs, and therefore it will cancel and replace its orders. So very quickly, just to illustrate, suppose that you have n different bins. So in the case of binary questions, is X going to win or X going to lose an election? There will be only 2 bins. But in principle, you could have 3 or up to 5 bins in some of these questions, where you have bins in which a numerical outcome, such as a gold price, can fall. Suppose the model generates a prediction P star. So this is the probability that the real outcome will lie in bin I, is given by Pi. The bot has a cash position denoted by Y, and asset position denoted by Z, which could be positive or negative. These are the sort of shares held in each particular bin. And the preferences are denoted by a function, U of W, which we call a utility function, where W is a random variable denoting the end of period wealth. So when this market resolves, the bot is going to receive some income from all the transactions that have taken place. And this is a random variable, and the probability will determine, the beliefs will determine the expected value. And the bot is going to maximize its expected value. So I won't go through the details, but basically you want to try to find the highest price at which you want to buy shares, the lowest price at which you want to sell, and you place the corresponding number of orders at those prices. Very quickly, an example where your beliefs, the machine model is predicting 30%, 50%, 20% likelihood. On the table below, if you run through this process with a particular set of preferences, cash endowments, and so on, that's my 15 minutes, so I'm going to wrap up. the table below gives you the prices that the bot will post. And this is what the trader would see. So this is an actually constructed market. Whether the approval rate for Japan's cabinet will fall in in each of these three bins. The trader can buy or sell contracts in each of these three bins. Here's the particular bin, the approval rating being more than 45. You can buy yes or no contracts. This is what the trader sees. This is the counterpart to what the bot has posted. If the trader then trades, that changes the bot asset position and the cash position, and this will cause recomputation, and you'll end up again with revised prices, which are then displayed to traders on that market. So that just speaks to the design, and I'll just wrap up. I know 15 minutes are up, but I'll take 30 seconds to just tell you where we want to go with this, and this is outside the bounds of the IARPA-funded project. Because that is too limited in the sense that the machine models that anchor the prediction market are too constrained, too heavily constrained to be designed prior to the knowledge of what you're trying to forecast. If you know what you're trying to forecast, you can construct much better machine models. And the application that we are now working on has to do with COVID prevalence. And there are a bunch of models that are submitted weekly to the CDC, epidemiological models with parameter estimated through incoming data. And they give you wide variation in forecasts across regions. These are hugely important forecasts. And you can think of, campus reopening decisions, travel restrictions, and so on. The models can, they can incorporate a lot of information, but they cannot incorporate novel qualitative information in the way that prediction markets can. For example, if there's a campaign rally scheduled, a high density event, a sporting event scheduled in a particular location, a governor changes their policy with regard to mask use, so on and so forth. These things can be incorporated into market prices well before they actually enter into the underlying data that can be used to adjust the model. And here's a quick example of one of these models, the Yu Yangu's very successful model for COVID prevalence. And you can see he's predicting order of magnitude difference in September, October between New York City on the one hand and LA, Chicago, and Philadelphia on the other. And by filtering this through a hybrid prediction market, the idea is to see whether or not one can improve on the machine model forecast. I'm going to stop there and just acknowledge David Rothschild for the earlier research, Danny Benjamin for the current one, my RAs, Amara Enverigi and Julie Seeger, and Aram Galstian, who was the PI on the IARPA grant. Thank you very much.
So thank you very much. I'm very happy to have the opportunity to tell you about collective dynamics of dark web marketplaces, some recent results where we investigated the emergence of a socio-technical ecosystem of dark markets. Thank you to the organizers for setting this up, Jessica, Chris, and Walter. A lot of work on their side, and we all appreciate it a lot. So this is a work done together with Abir, who is now at Chainalysis together with Leonid, Daniel, and Philip. This is a strong collaboration with Chainalysis of our team, and it's part of her PhD work. She concluded her PhD at Sethi in January this year. And then with Laura, who's now assistant professor at DTU, and Alex in Oxford. So what are dark web marketplaces? Well, they are dark websites accessible with Tor. So you just need to use a different browser to access them. They sell all kinds of goods, including drugs, weapons, and stolen information. And they use Bitcoin for payments due to anonymity, or also other cryptocurrencies. You have a couple of screenshots here. You can buy there an AK-47 or fentanyl or a lot of other stuff. Everything started with Silk Road in 2011, and you see this is a screenshot from Silk Road. You have goods for sale, LSD, for example, MDMA in this case. You have the price in Bitcoin, you have reviews from users. So it's very much like commercial websites we are familiar with. Of course, the kind of good they were selling was not appreciated too much by law enforcement, and Silk Road was raided in 2013. This is how the CBS at the time told the story. A secret website called Silk Road that played host to a massive black market drug ring is now offline. 32 million were seized of dollars. The admin was arrested. A number of agencies contributed to the seizure. So was this the end of dark markets? There were at the time, for example, this is from the official FBI website, Statements like this seizure sends a clear notice to those who think they can commit crimes in digital anonymity. The resolve of the government is strong. However, it became immediately clear that the war to dark markets was not so easy. First of all, Silk Road was not allowed, there was already ship marketplace, and then in the few months that followed the seizure, at least 2 more dark markets appear, Pandora and Silk Road 2, and the situation is still like this. So this is 2020, you see seizures go on, actually now they involve more agencies than before, also international collaborations with Europol, for example. But as you can see from this screenshot of the news, even in our pandemic, I mean, dark markets are in business and actually quite reactive to that. So a paradox that has been noticed by many is that dark markets are very unreliable. If you are a user, you are at risk of losing your money due to scams, seizures, and of course there is no customer protection. Yet they proliferate. So, motivated by this observation, we wanted to understand the root of the resilience of dark markets, and we produced an analysis that I'm offering you, and it is presented also in this recent preprint. You can see the reference there, where we show that resilience is a systemic property of the system. That is, dark markets really form an ecosystem, and a single market closure has little impact there. Why? Because users migrate in a coordinated fashion to another market very rapidly. So it's a swift migration. And so from the point of view of the user experience, you also have very well populated markets. This is like the take-home message. Now, of course, I'm telling you all the details. So data. First of all, it's important to stress that we look at Bitcoin transactions. This is important because previous studies analyze user surveys and partial listings. We can really look at the fluxes of money inside and those markets. Why is this an achievement in itself? Well, because Bitcoin transactions are public. So if you don't need to be familiar to Bitcoin. Bitcoin is a cryptocurrency, and you know all the transactions that have ever been made there. However, data come to you in this format. You have an address sending money to another address. Now, you not only don't know who these addresses belong to, but also these are addresses, so it's very easy for a single user or a single entity, a single company, to create many addresses. So you don't even know what's the entity they belong to. So pre-processing is absolutely needed. In this aspect, the collaboration with Chainalysis proved fundamental for us, and following the methods detailed in those papers, I don't want to go into the details, it's important to understand that there are 2 problems that need to be solved in order to make Bitcoin data usable. The first one is clustering, so it's understanding which addresses belong to the same entity. It can be a single person, a company, a marketplace. The second one is labeling. So, given the clusters, who is whom? So Silk Road Market is, for example, this. Chainalysis are expert in doing this. This very huge majority of the data remain anonymous, but they are now much more usable, and they are proper transactions from an entity to another, time-stamped with the amount. So this is our dataset. We have 356 million transactions. We have 69 markets in total. We focused on 23 for a series of reasons, including the fact that we wanted to check at closures, and the information about those closures were important, plus they were very big. We chose the biggest, and the data were cleaner, etc. And this is the timeline. So we start in 2011 up to when we terminated the analysis in 2019. And you see most of them are not alive anymore. You have color-coded the reason for closure. They can be raided, scam, voluntary closure, and a few were active still in mid-2019. The total volume in transactions that we observe is $4.2 billion. And more or less it's equal the amount that enters in these markets and that leaves these markets. So you can also have a clear indication of the fluxes there. So the question is, what happens after a closure? And not much, actually. That's the thing. So you have a sort of whack-a-mole game in which you see, this is, for example, the number of markets. And you see, I mean, there is not really an effect of closures, either raids or scams, as to like disincentivize people from creating new markets. So if you see this temporal series, it's even hard to guess where closures are. And the same, probably even more importantly, is true for volume. So this is volume in time. And first of all, you can see that there are two time series there, and that our 23 chosen market make up basically all the volume we observe. And second is that after a closure, maybe you have a little drop in some cases of the volume, but it really goes up quite quickly and it stays up. The general trend is unaffected. We did also some more detailed analysis for this, but I mean, the message is that they keep growing, the volume keep growing. And why? Why is that? Well, here we have the value of the markets normalized at the day of closure. So the day of closure of the market we are targeting, it's the normalization factor. So the value is 1 there. And you see on the left side, on the left panel, the closed market has a gigantic shrinking in volume. Notice that the volume goes down before the official closure for two reasons. First of all, there is noise on the exact date. Second, in some cases, users start noticing something weird and abandon the market a little bit before, for example, the scam. And on the right, you see that the volume that has been lost from the closed market goes to the coexisting markets, which increase their volume by a factor of 10 or 15. Now, consider also some of them are small. These are average curves. Of course, you have interval bars. But you have this transference of volume. How does this happen? Well, we need to go and check the user behavior. So this is a migration process. You have two dark markets in this case, which are the white nodes at the center, Silk Road and ship marketplaces. These guys are the Silk Road market users, and you see some of them are special because when Silk Road shuts down, they move and start interacting with ship marketplace. These are the nodes that we identify as migrants. Other nodes will not interact, even though they would be expected to interact in normal time, and they are non-migrants. And then you have also this node that is not a migrant because it was already a ship user. So migrants are nodes that started interacting with the second new marketplace for the first time after the closure of the previous one. They were customers too. And this is the timeline of closures. You see, this is to be read in clockwise direction. You have Silk Road marketplaces, and the arrows indicate fluxes of users. So Silk Road marketplace sent most of its users to ship. Ship then was shut down and sent its user to Silk Road to market. Silk Road to Evolution and Agora. Agora mostly to Abraxas, but also partially to Nucleus, and so on and so forth. So you have this reshuffling of the users that simply change platform but remain mostly the same. And actually 85% of them, of expected returning users, are active within 5 days from the closure of the original market to another market. So it's a large proportion of them, even though not all of them. But you need to consider that some of them will do everything in their capability to like mask their future activities after a closure. And these 85% are also more active. So they are also, this contributes to the preservation of volume because those who migrate are actually more active actually by a factor 10, both when you look at dark market transactions, than when you consider all transactions in general. So where to migrate to? This is a coordinating in the dark problem. So you see, when alpha buy market closed, you had several, as a user, you have several other options. However, 71% chose Hansa in our dataset. So it's pretty coordinated migration towards one market. And you see that if we look again at the plot we have seen before, but now divide in the right panel the growth in market, the top destination, in a market-to-market fashion, the top destination is clearly getting most of the volume of the recently closed market. And the second destination is way less important. The average share of users migrating to the top destination is in fact 66%, and it's also important to notice that the users migrating to more than one market are only 4%. So most of them migrate just to one. Which is this market? So how is the collective decision made? Well, we ranked markets at the moment of closure according to their volume in US dollars or common users, that is, users that they were sharing with the closed market before closures. These are not migrants, therefore, but they may be relevant. And you see Hansa, with the top destination, is actually first in the common users rank. Then you have systematically the fact that the Russian anonymous marketplace has a high volume, but is not a preferred destination. And this is probably because it's in Russian, and there is also geographic barriers there. So you see that if you look at common users rank, this is the collective decision. This is the actual choice of the top destination versus a random selection. And a trade volume rank seems not to work very well, but if you exclude trade volume rank, if you exclude Russian markets from there, the trading volume is the main predictor. So in summary, in this ecosystem of markets, market closures are not effective because users migrate together to the same alternative market, preserving the user experience of a very rich market. Influential users are more mobile, and it's possible to predict where they will migrate. Results are in this preprint. This is a very active line of research. Now we are looking at the effects of COVID, for example, and we are detailing buyers and users and the peer-to-peer network. So many more results will come. Thank you very much for your attention.
Okay, so now we're going to do the Q&A session. And of course, the questions are for all the speakers. And we're going to start with one for Eric, which is, says here, what problem was the current voting system trying to solve? Was it a good idea at the time?
Well,
Eric, are you there?
the current method in the US is primarily plurality rule, as I mentioned. So everybody votes for one candidate. I think the only principle that does a good job on is making vote counting easy. If you're only voting for one candidate, tabulating votes is not a problem. And this probably was a concern in the 18th century when we adopted this voting method. Now it's of course no longer a major concern at all. We have high-speed computers and we can use essentially any voting method we want.
Okay, thank you, Eric. A question for Rajiv. How exactly do bots improve the predictive qualities of markets?
So the bot is just representing the model. So one can ask, how is it that the model becoming a participant in the market improves the predictive quality of the market? Or alternatively, you could ask, how does the market improve the predictive quality of the model? So those are sort of equivalent questions in a sense. And that's a research question that we want to actually test empirically. But my intuition would be that they improve each other. The markets improve the models improve the markets. The models allow you to have liquidity in the markets. Even if traders are not very certain, the model will give you some anchoring. It'll give you some prices at which you can buy and sell. And it's a bulwark against the kind of manipulation that I talked about. So that's one way in which the model could improve the market. Market improves the model because it can take into account very quickly qualitative information that the model just can't do until that information just gets translated into the machine readable form that the model is then going to operate in. So they work to improve each other. At least that's the hypothesis, but it's a testable hypothesis that we want to test.
Thank you. A question for Andrea. So it says here, does the concept of efficiency apply to dark markets in the same way it does to conventional markets? And what is being optimized in dark markets, if anything?
Yeah, that's a very good question. Can you see me? Yeah, I don't see myself. Okay, okay, cool, thank you. And we don't have information about prices, or better, we didn't have information about prices of goods and listings at the level of the analysis I've presented now. We have started looking at this aspect. Of course, getting the data is not super easy, but we are improving a lot. What we did is we checked the transactions, but we don't know what a transaction corresponds to at this level. I use the word efficiency because what it seems they are very capable at doing is this coordinating migration from the shutdown market to the same other market, which somehow guarantees that the system as a whole persists even after closures or due to scams or police intervention. So this is how I use the word efficiency to this point. Your question is very interesting. As far as I know, nobody has yet looked at pricing dynamics there.
Okay, thank you. Here's an out-of-the-box question for Rajiv and Eric. It requires maybe some creative thinking. It says here, the build-up to the election is in a way a test of the candidates. Could we combine Eric's voting algorithms with prediction markets or something similar, so that voting's not just a one-time thing, but kind of a dynamic evaluation? So moving away from this kind of point model of voting to something that's dynamic, evaluated over a period of time. Eric or Rajiv, you want to try addressing that?
Eric,
sure. Would you prefer to say something, Rajiv? I can start. Maybe
I'll follow you, Eric. You go ahead.
Okay. Of course, one of the difficulties in making predictions in general elections based on events that occur before the general election is that we don't have as good information about voters' preferences as we might like to have. That's one additional advantage of the sort of ranking systems that I was advocating. We will have more information about voters, even voters who didn't vote for any of the candidates, who didn't prefer any of the candidates who end up in the general election will have the opportunity of expressing their preferences in primaries about those candidates. And so if our prediction models are based in part on what goes on in primaries, we will know more about voters' preferences.
Mm-hmm. No. Rajiv, you have anything to add, or should we move along?
Just very briefly, I don't know if this is what the question I had in mind, but when somebody drops out, for example, people may want to reevaluate, or when new information comes up, and this happened a lot with absentee voting and early voting, right? Because people may have voted when a whole bunch of people dropped out of the Democratic primary, they then didn't have the opportunity to change their votes. But I think Eric's systems takes care of that. Actually, it'll just act as if those people had not been preferred and move on to the next person on the list. So I don't know if this is what the person had in mind, but that's what it made me think of.
Okay. Another question for Andrea. What's the difference with classical segregated markets, meaning markets on a type of specific product, does the ecosystem follow the same migration dynamics, or is it specific to the dark market?
Yeah, that's a very good question. So there are a few markets that are more specialized than others in the dark web. Like, for example, there's one that used to specialize on stolen identity and stolen credit card information. Most of them are generalist markets. And at the level of our analysis, the best predictor to understand where they will move is the volume of the market itself. So it seems to be sort of generalist dark web versions of services as eBay, if you want, of course, with a huge difference due to regulations and goods sold. So the answer is we haven't looked at this. It seems that the migration is from a generalistic market to another.
Okay, thank you, Andrea. Another question for Eric. It's sort of a technical question about majority rule algorithm. So if a majority rule were adopted, then what happens when a Condorcet cycle such that A is greater than B, B is greater than C, and C is greater than A in transitivity actually occurs? Flip a coin or revert to Borda count?
I didn't have a chance to talk about that, but it's naturally something that voting theorists have thought about. You could make a good case for either the Borda count or for a randomized procedure, depending on, again, what it is you want out of a voting rule. There's a sense in which majority rule and Borda count are really the two best of the many imperfect voting systems we have. And so using Borda as a tiebreaker is a good idea. But there are also some circumstances where if there are three candidates who are cycling, you might want to determine the winner at random. I should point out that in reality, the evidence suggests that kind of cycle almost never occurs. We have a lot of evidence on this from Australia. Australia has been using ranked choice voting now for over 100 years. So we have thousands of elections for which we have data. I had a student recently who looked at elections since 1993, 1,500 elections in the lower house of parliament in Australia. There was not a single example of a voting cycle in that data. So it's a theoretical possibility, but it's not practically very important.
Okay, thank you. So maybe one final question for all three of you. Here it is, let me get it. It seems like all of you could say something about this. So where is it? Oh yes. So these algorithms that are being discussed are, to some extent, I mean, they're about consensus in different forms, and they separate or treat only the voting process, and they keep it separate from this evidence accumulation process the voters use to make a decision. Could we design an algorithm that also takes that evidence accumulation process into account? Is there any way that we could think about that, or directions to move in?
Well, interestingly, Condorcet, who was promoting majority rule for the purpose of aggregating disparate tastes or disparate preferences, also was concerned about aggregating information. And it can be shown, and Condorcet was the first to show this in a limited way, that majority rule has very good information aggregation properties as well as preference aggregation properties.
Interesting. Rajiv or Andrea?
I think if the spirit of the question is that some voters are going to be basing their decisions on more thorough parsing of the evidence or greater information than others, then I think you're going to end up, anything that accommodates that is going to end up violating anonymity then. And so that could be a problem. You know, which is continuously discussed in democracies, is, low information versus high information voters. But ultimately, you may want a system that preserves anonymity, even at the cost of not aggregating information all that well.
Mm-hmm. Andrea?
In the cryptocurrency space, there are these decentralized autonomous organizations where the voting ends at a given time, but you have the whole history visible, and basically you can continually change your opinion, which somehow incorporates this to an extent. Mm-hmm. And it's all very experimental though, and understudied so far. But it's very interesting.
Okay, thank you guys. That was fantastic. And I think I'll turn it over.
Could I just follow up very briefly on what Rajiv said on different voters having different qualities of information? It's sometimes argued in this country that we should have mandatory voting, compulsory voting, so that everyone gets out and votes. But if what you're concerned with is information aggregation, then actually compulsory voting works in the opposite direction, because you're forcing people who actually haven't thought about the problem very much to go out and vote, and that just adds noise to the system. So an important argument against mandatory voting.
Interesting. Noise, of course, can have complicated role in things. Okay, guys, thank you so much. That was fantastic. I'll turn it over to Chris now to wrap things up.
Thank you very much. Thank you, Jesse.